Hi, everybody. Today we are covering a project created in Archicad. Good afternoon, everyone, and welcome to the Archicad User Group webinar series for 2024. If you don't already know me, I am Matthew Phillips, the Western Cape representative for TotalCAD Solutions Center. I will be your host and moderator during these sessions. So without any further delay, let me introduce our presenter, Paul Elliott from Paul Elliott Design Science. He will be giving us a short presentation on his latest architectural marvel, a core-clad mass timber house crafted using Archicad. Over to you, Paul.
Thank you, Matthew. And welcome, everybody. I see there's only 21 people, but I was expecting more like 200. But anyway, here we go. Right, here, this is the mass timber carbon neutral house edition that I was able to build 5 years ago. It was on part of what is our family home here in Newlands in Cape Town. It's in Pembroke Lane. My father was an architect, and you can see here this was the original house built in 1975, and then my father built on a studio in 2000, and then we subdivided the house. You can see here the green line, which subdivided along this line and kept this for me and my family and sold the rest of the plot. So that was about 1,000 square meters that we sold off, and we kept 365 square meters. And this is for me and my family. I have, Stephanie and I have 3 sons, so we needed to enlarge the house. And I'm going to show you what it is, and it has been published on the Arc Daily site. So if anybody wants to have a look at it, it's on Arc Daily under my name, Paul Elliott. So why mass timber? So it's a material, a new way of building. I mean, some are saying in Europe that if the 20th century was the century of concrete, then the 21st century is going to be the century of mass timber. Mass timber was first manufactured in Austria in about 1980. And it's called mass timber because it has to do with large pieces of timber that are either glulam beams or columns, or cross-laminated timber panels, which can be used for floors, walls, and roofs. So they're saying the 21st century will be the century of mass timber. Why? But it's mostly applicable to Europe, and Canada, heavily forested countries, because it's a sustainable way of building. It's the time of in a time of energy transformation, where we're not relying on trying not to rely on fossil fuels anymore. Environmentally sustainable. I built this at the time of our water shortages here, and our normal building practices are water intensive. So that was a factor in the choice of the material. Fast, clean, and no noise pollution. You'll see that I'll show you the construction process. House is assembled very, very quickly. It has tremendous health benefits. The materials are natural, and there are no toxins used in the manufacture. You'll see that the house is mass timber, but I've clad it with cork panels, and it's also a very healthy material, natural. Its orientation is northeast, which is optimal in our situation here in Newlands, and it is based on evidence-based design. Types of buildings used and built like this before. I use the geometry methods to set up the plan and the section. It is a way of building more with less. And in our time of information anxiety, we have created a peaceful environment. So besides the building type, I've tried to create an environment which is a peaceful one for my family and I to live in. So here you can see there's a river running through, and now that river is a seasonal watercourse. So, you know, it's not running at the moment because we haven't had much rain, but it just because Newlands is actually a very wet area, and it's on the lee side of the wind, the northwest wind. So a lot of rain falls here, and also it is the home to many springs. So over the years, many breweries have been built in the Newlands area because of the water springs that we have. So that seasonal watercourse is also the overflow from a spring that we have up the road on the other side of the Newlands Avenue. So when I made my application for the subdivision, this is where the existing house is. This is a cul-de-sac. I had to provide a construction method statement. The title deed said that there was to be a setback of 5 meters, 5.5 meters from this wall at the back here, which gives onto the Sachs school boarding house. And the servitude is because of a pipeline that was an original water supply to the breweries, the Olsen breweries, which are down on the main road in Newlands. So the title deed setback is huge, as you can see, as the pipeline is only 1.5 meters. They added another 4 meters onto it. And then further to that, we had to do a survey, an eco survey regarding the water, and that we had to prove that we weren't disturbing it, and the researchers had to determine water life, and then they said, okay, well, from the center of the river, you need to set back 2.5 meters. So that gave us really 2 open spaces from the existing house, the proposed to the new, and I call this the river court, and I call this the garden, the paradise garden here at the back. So when we built, now you can imagine it's not an accessible site. So we had to build a concrete footings. We had to build concrete footings, and we had a team of guys coming through here, going across the temporary bridge with wheelbarrows full of concrete over a day and half a night to build, deliver, and to cast the concrete footings. Once that was done, we brought in the glulam beams, and then all the panels had to be lifted over the existing house onto the new site with a crane, an enormous 90-meter crane. I was inspired by a Japanese type of house, which is found in Kyoto. It's a townhouse, and it's called a machiya. Now, a machiya typically is a one-family house and a business. So you would have on the front of the house, you would have a shop. You would then have a series of internal courtyards, much like we have, and a circulation route to get to the various parts of the house. And sometimes there might be, normally there was an upstairs that you would go to. And the whole family would live there. So you would have entrance, business space, living, working, dining, reception space, and then a storage space at the back. So our house is much like that. And then another phenomena that I looked at in Japanese architecture was this notion of movement space. So my father's house is very geometrical. It was designed on a Le Corbusian model using a modular brick pier system and a pinwheel arrangement. So that was quite a geometric, almost Palladian type of space experience for us as we were growing up. But this one is not like that, and it has to do with a notion called movement space, which is that in the Japanese traditional Japanese houses, you move from room to room. You don't go down corridors as we would mostly do in houses that have been built around here. So you would come in the front door. There's a carport, and there's a lobby here which you go in, and then on the left here, on the left here is my office. Then is somebody talking? And then we have a bathroom and what I have converted in a small bedroom for one of my sons, and then a kitchen island with a living dining space and an outside patio where one can have breakfast, for instance. Then there's a bridge across the river, which is open and covered. And then in here we have the addition, which is the mass timber part, which has a central double volume space with an ensuite bedroom and dressing area here, and another bedroom at the back, and a library here, and then a little attic situation above it. So you'll see here in more detail, these are the plans that I submitted to Arch Daily to explain the rooms and their designated purposes. So here you can see the long section across the site, and this is the section, the long section across the river and the courtyard and the cul-de-sac entrance over here. The existing building was a brick building using the traditional cavity walls that one uses here in the Cape. It's wet and damp, and it then has a steel and glass addition here, which was my father's studio. Obviously, this is obviously northeast facing, and then we built the timber addition here. So it's a collection of different families of materials. And as you probably know, the timber house needs to be raised above the ground, which also helps deal with the dampness of the ground here in Newlands. So it is a very simple construction, and I hardly did any details, I must admit, because we have the glulam beams you can see here support a 165 millimeter thick cross-laminated floor slab made of pine, SA pine, and the cross-lamination is what strengthens it. And those, I think those were 5 layers of pine, 3 layers here for the wall at 100 millimeters, and then the roof slab is also cross-laminated timber. So from inside, you've got this feeling of being inside a timber building, and then on the outside, it's clad with cork, which is a very simple batten system that sits on a vapor barrier, and then just has the cork glued onto the battens, and then the same cork panel is used for the roof. So as you'll see in the photos, this is a total monolithic effect that I created here. These are some isometrics north and west, just showing you from the school, the addition and the existing, and then from the road, the existing and the addition. I started using Archicad at Archicad 6. That's quite a long time ago. And I remember when I was living in Germany, in Frankfurt, I went to the fair there and was bowled over by this architectural CAD. I mean, it's not really CAD, but this BIM system that was invented by the Hungarians. That was, I think I saw version 2. And so then I said, okay, when I make enough money, I'm going to get this. So I did. And then here is another few views that's looking across there. You can see the bridge, which is an open space. It's very nice to use when the evening sun comes in here. And this is the garden where we built a pool, vegetable garden, and planting, as you'll see. And that's looking from the southeast, which is the shady side. So we started building this before COVID, and then we were forced to stop, of course. So we actually used this as a running track, this space on this side of the river, which we could in order to exercise when we weren't allowed to go outside. So there you see the cul-de-sac. The existing house is there. That is the portion we kept. We built a carport there. I mean, the carport we enclosed. This is the river court. This is the steel and glass studio, which my father built for him as he worked from home. He was the university planner at UCT, mostly known for the middle campus at UCT, and he did some buildings at the University of Western Cape and others. But basically, he came from Zambia, where I grew up, and he designed a master planner of the University of Zambia. So his thing was university planning. So this is where he worked from his later years. And then my mother and my father moved in there, became a granny flat, and my family and I moved into the house. So when they passed, we moved into here, and we were living in very cramped circumstances as we had to wait out COVID. but we did manage to build a garden at the back so we could use this very a nice eco pool here, and then this entertainment space at the back. This is the wall against Saks, which I painted in this color, and then the base also reflecting the color of the dark earth sand, as you'll see here. This is a Japanese maple, which we decided that we wanted to keep. So I had to move that foundation across a meter so that it wouldn't disturb the maple's roots. So Jamie Smiley is the man who started cross-laminated timber production in South Africa. And I don't know if maybe you Cape Townians will know of the Ayrton warehouses out in Retreat. So he rents one of the warehouses, and that's where he produces these panels, which are done in an 8 by 5 meter pneumatic press. So you can see here how the panels are laid crosswise in one direction and then the other. They are glued and put in a press, and they come out bonded together and are then cut up by a computer-controlled saw, to which Jamie fed in my Archicad model, which he also had Archicad. He fed the model into, I mean, they used the model to break up the piece, the house into pieces. And then they fed these into the computer-controlled saw, which cut the pieces, even with their rebates and everything. And then they were delivered to site. So they have to be delivered to site in the order in which they're going to be installed, which is the first trick here. This was a mock-up that we did in his factory, which I condemned because it was done before he got the computer-controlled saw, and there were inconsistencies. So I condemned this and then waited out. This is like even pre-COVID, and then he got the saw, thank God, and made the panels. And then we had this crane, which you can see here. That's a huge crane. We had to cut a swathe between these two pin oaks here, and that's a panel being delivered. So onto the cross-laminated beams, which are huge. It's another thing I forgot to say, is that this is Jamie's first house. So he used, because he was in touch, connected with the Austrian manufacturers who helped him set up, they suggested he use a German contractor. So Germans always oversize things. So these beams are huge here. They don't necessarily have to be this huge. But anyway, the slabs come onto the beams first, and then the panels are put up. And you can see here they use, I had funnily enough again, two German carpenters who had worked with CLT before. So it was quite an easy process. It took 3 days to deliver and erect the panels to get the carcass finished, which is an incredibly short period of time, considering that my neighbors renovated their house next door, or the house that my father built, and it took 6 months, and it was a hell of a disturbance to us because it's pollution, it's cement everywhere, it's noise, our building process is antiquated. When I visit Europe, my friends say, "Are you still building in wet construction?" Because they don't do it in Europe anymore. Everything is dry construction, and with good reason. So here the panels are going up, and then this was the bridge that crossed the river, and then they started the process of cladding with cork. Cork is an incredible material. It's derived from the bark of the cork tree. It's renewable. It is water resistant, thermal, antifungal, acoustical, structural, and that has sensory qualities. It allows for this monolithic type of image here, or appearance, because I decided I used it for the roof as well as the walls. And it reduces reliance on multi-layered synthetic components, healthy interior atmospheres, and it can be recycled. So this product, how did it come about? So it can be made from recycled cork, in other words, waste from wine stopper production. But what they found in Portugal, where it comes from, because most cork oaks grow in Portugal and in Spain, they found that when they introduced the screw on top for the wine bottles, a lot of their market for cork stoppers evaporated, and they invented this this way of making panels, in this case 50 millimeters thick, by using autoclave to bond particles of cork that are bonded or glued, held together with their own resin. So there's absolutely no chemicals involved here. And here you can see a detail of what it, I mean, this has been standing outside for 5 years, so it's a bit tatty, but you can see here the panel on the inside is the cross-laminated timber, which has a vapor barrier. There's then a batten, and in this case, a plywood sheet, and then the cork is either screwed on, as in this case, or glued on. So I did away with this for the walls, but not the roof, because the roof I then had to waterproof plywood and then put the cork onto that to make it, you know, waterproof. So here you can see the vapor barrier is put in, and it frames the openings, and then the windows are put in, and then the cork cladding happens, and the windows are put in with the frame around, all done by the same carpenters. Here are, when I decided to publish it, I got in Danny Nell, who's a very good photographer, to take some photographs of the house. This is about the cork details. You can see, in this case, it's after the rain. So the cork, I call it the living material. It changes, you know, this is the north facing, that's the south facing, changes in the light, changes when it's wet or dry. And it is super nice to touch. I think the only problem I have with it is, okay, so the cats love these corners, right? So this is where they come to sharpen their claws. So some of the corners have been damaged, but other than that, we love it. It's a breathable, living material, and is full on carbon neutral, which are values that I hold dear. Unfortunately, the rest of my clients in this country don't. But anyway, hopefully, as my father always said, this country is 10 years behind everybody else. But okay, so here outside, this is the Paradise Garden at the back. Again, another one here with a flow form fountain. We use recycling water. We recycle the water here to create this fountain. These are principles of Islamic gardens, green and water fountains, to provide delight and meaning. The river has a life of its own. It can sometimes be very virulent and loud. It's like, again, a living thing. So that's the riverside with the maple that we kept. And this is a homage to my father's house, had this as a front door, but it's really from the Chinese gardens, the so-called moon gate, or this idea of stepping out through an opening into another world, the idea of the inside, the outside, and into the garden, the house, from the house to the garden, and make for very pleasant openings. You can see right through this house from here to the front door. So that was another factor in my design, is to create viewing angles and transparency. And then here you'll see some of the inside. This is the central space. There you can see the double volumes, created by the setbacks and the sloping land. I managed to get a little library at the top there with this somber stair here, looking down into the space. And then the bedrooms, I used folding doors because I wanted to maximize the inside-outside experience rather than sliding doors. Here is the view to the deck outside on the north sunny side. And then that's an example of view through. So we didn't have any corridors. So these intermittent rooms, I call them media rooms, because, you know, my children's bedrooms are small because all they do is sleep there. Whereas these media rooms is where I said they can put their computers and their Wi-Fi and that kind of stuff. So You'll see here, this 2x2 room is my youngest son's room. And that is the media room outside. And this is his gym where he trains. So, you know, that's the whole idea about this house, is that it can be flexible and multi-purpose. And that, say, over time, if you want to put in a door here and make that an Airbnb room, when your sons, you know, leave and go and study overseas or work overseas, then these things can be done. I then built, I mean, this timber bridge was there, but we covered it at a later stage with the stair, which is also made of cross-laminated timber to provide covered access, but also is modeled on what you find a lot in Turkish houses are these outside entertainment rooms covered, you know, facing the afternoon sun, as you can see there. That's the river in full flow. There's another deck up there that we use. So the house provides lots of opportunities for space use. You can decide to be there in a summer morning for breakfast and here in a winter's afternoon for tea, you know. So the idea is that that the house can be used in many different ways. So this explains the reason for the form. There is in zoning, you can only go to the boundary for a certain length of the perimeter wall if you are in a setback of 3 meters and under a height of 4 meters, which is satisfied on the northwest side, and on the east side allows me to gain this extra space for the loft that I showed you in the photos. So here you can see stepping down with level difference of 400 millimeters, and then gaining this library and the storeroom over here, and then this nice almost double volume space. These are elevations, diagrammatic elevations, and then again the section through the river. Orientation is important to me. When I designed the Mitchell's Plain Hospital, I found this diagram, which I found is very interesting. It's William Atkinson was, I don't know if he was an architect, but anyway, he almost like more than 100 years ago, he pointed out that if you put a building facing directly north, you're not going to get any sun on the south side. So if you turn it on the diagonal, you can get sun all around. So our square plan for the Mitchell's Plain Hospital allows sun to get to the wards at the back, whereas in that case, those wards wouldn't get it. So in Cape Town, we have this phenomena where the city grid, which is square, actually faces north on the diagonal. So we are we are lucky that way, and hence even in Newlands suburbia, it's the same grid angle, and we're able to get the northeast aspect, which is very nice. The west sun we don't get so much, but that's mostly because of the mountain. I use geometry and notions like the Japanese tatami mat to organize the space. You can see here that I worked for a Spanish architect, Bofill, who introduced me to geometry. I didn't learn any of this at university. It's how if this guy is Pythagoras, he said all his number, but you know, the Greek tradition, the Egyptian traditions, which eventually were inherited by Islamic architects, all looked to nature for their proportioning systems to create beautiful things, whether it's a vase or a temple or a house. And so I use some of those ratios and notions to set up the room proportions. And you can see here in the double, the Seca Pisces, or the double two circles intersecting to create, you know, that the geometry of that central space. These are squares, so simple, but just to let you know, this is part of my design process. Okay, this is an aside, but Matthews thought he said I should just show it to you. Anyway, I'm sometimes lecturing at the School for Explorative Architecture here in Cape Town. It's a new school. It's been in existence for 3 years now, but 2.5 years. They asked me to talk, and one of the things that interests me, and it was through travels that my family went on before I studied to be an architect, was this notion of African space. And my father had talked about it because the house he designed here is one of many houses. He designed another 6 of them in Ndola in Zambia when we lived there. And he talked about this notion of the pinwheel being the center, being the African marketplace, and then the wings going off around it were the bedrooms and the kitchens and the dining rooms and things. So this notion of a lapa, or the bilobial space that we find in our South African vernacular architecture, is dear to me, and unfortunately it is being lost. But I remember visiting these places as a kid, and this fantastic use of space where you have these 2 lobes. The one lobe is around the hut in the front for, say, cooking and receiving guests and entertainment, and at the back you would have the kraal, or the place to keep your grain and your domestic animals and things like that. So that notion was used extensively around the Pretoria and Gauteng region, Tshwane. And here you can see the various levels of social space: the communal, the semi-public, and the external living. And so that was the idea from the Japanese houses or the Arab houses. You don't let everybody into your private internal space. You have various rooms, social rooms, that have various purposes. Peter Rich, who is an architect and written about it and taught it at Wits University, this notion of African space. Franco Vascura, his lovely work on the analysis of vernacular architecture, all inspired these notions of African, or recorded these notions of African space. So here you can see how this is a palace where they have the various levels of social interaction going back. Anyway, this is an aside, but it's something I'm concerned about, because our architecture needs. We need tradition. We need to be reminded of the meaningful things. I think we've lost our way in this secular world, and this is another type of tradition. Barry Bierman was a historian, where they record the colonial or the European space that came to South Africa, the H type, the T type, the U type, Stadhuis, Landhuis, Sinkplaat. So there's this family or this tradition that we have in this part of the world that interests me. The evolution of the house, Zulu hut, Xhosa hut, very much like Mongolian yurts, igloos. I'm interested in the circular pattern of space. It's a very economical way to build. If you look at beehives and things, the bee is a very clever insect. It makes use of minimal space to build its quarters. The dome houses, the Dymaxion house of Buckminster Fuller. And then I came to this notion of a trilobial space, which I was fortunate enough to find a client to test out my idea of trilobial space. This is my house, this house I've just told you about. This is a lodge that we built in Botrivier, which the client built as a kind of a place where people could come and live and stay for a short time from overseas. But basically it centers itself around a lapa, or a central space. And it has 3 wings. One is a living dining, and then 2 en suites. One could be a study, one could be a living room. So this is also built with mass timber, but I learned lessons. My house is overcomplicated, and this is a simplified version. And the reason for that is that the mass timber is not that cheap. It can cost you 15,000 Rand for a cubic meter. So it's best used in simple buildings and mass-produced and modular. That's what it's used for in Europe. And in Europe, they build tall buildings with mass timber, 40-story buildings, whether they be office buildings or residential buildings, sometimes in a hybrid fashion around a concrete core, sometimes on top of a concrete plinth. But its versatility and it comes into its own in the simplified in its simplification. So here is a very simple application of and this house cost considerably less than my house did. So live and learn. And then this just shows you that a client of mine in Limpopo, and again using notions of African space, I did this project, which I don't think will be built, but it's just to show you this idea of the vernacular. You know, the vernacular that I showed you. These are mud and woven and wattle and daub buildings, but they started building with concrete block and zinc roofs, which is not really a healthy way to build. So, you know, I mean, getting back to this theme of the relevance of mass timber, it is a very healthy material and is very good for the environment. Thank you very much.
Thanks, Paul. Thanks so much for sharing with us your projects. I think we're going to move into questions. Does anybody have a question? Just unmute yourself and ask away.
I was wondering how did you deal with just plan approvals, building plan approvals? If that was an issue.
Thanks. Is it Fritz? Yeah, thanks.
Yeah.
Okay, so timber buildings that are under 2 stories, because you're right, this is a new type of timber construction. But if it's under 2 stories, they weren't concerned as to things concerning fire, which is a question everybody asks. So I was able to get a plan approval for it that way. But if you're looking at a taller building, the regulations at the time didn't allow for it, but they do now. There is a unit at Stellenbosch University that deals with fire in buildings, and the necessary regulations are in place for tall mass timber buildings. Funnily enough, the director of the institute at Stellenbosch, his name is Mr. Brandt.
Question, Paul, Gert Bolt in Pretoria.
Okay.
Availability of skills obviously is an issue. How does one find a team which would be able to get involved in a project?
Yeah, Gert, best ask Jamie Smiley. His company is called XLAM, but as I say, my house was directed by a group of German carpenters, and they used local labor under their direction. Jamie has told me that in Harrington Street in Cape Town at the moment, they're putting a 3-story penthouse addition on top of a 7-story concrete building. So I guess it has to be managed, and Jamie has been doing this for 5 years now. So it probably, yeah, I mean, it's not labor intensive because it's so quick. And you need, you know, the crane is holding the panel while you put it in place. So 2 or 3 people, I guess, per panel. So it's doable. You just need diligent carpenters.
Right. Yes. No, of course. No, it's fascinating. You know, there are various materials which are similar but completely different because they're not timber. But you know, I've been dabbling with these things and see how, you know, how one can combine them. Mostly hybrid, because to embark on a fully fledged project, you know, we architects are maar bangbroeke. You know, we don't want to stick our necks out too far in one go, except if it's your own house. Then you can obviously carry on as you like, you know. So yeah, so I was, you know, we are in a position where we're going to be looking at that in the very near future, along the coast. And I think cross-laminate timbers might just be the answer. I love the cork. I was just looking at, I came across some, I think it was on the Zine website or some, you know, I think it was this morning, about a house which was also clad in cork on the exterior, and it just looks so smooth. You know, it feels must obviously be fantastic material.
Yes.
To even be close to and look at and touch. You know, so yeah, I would be very interested to get my thoughts around this. So
yeah,
well, thanks for the presentation.
Absolute pleasure, Kurt. Yeah, and it's really the tradition of the architects, the Japanese, and say some of the Finnish architects like Aalto and them placed great emphasis on natural materials and tactility, and certainly cork wasn't used. I think Aalto used it as an insulation material in Sanjatsola in the town hall that he did. But it really came into its own in Portugal, and the Portuguese pavilion at the 2000 Expo in Hanover was the first building clad with cork, and the design was by Álvaro Siza and Eduardo de Sutamura. So that I actually saw that building when I was living in Germany. So that's its first instance, but it has been used widely.
Hi guys,
in
I don't know if
Portugal and Spain.
It's okay. I'm sorry if I'm speaking over somebody. I'm just not able to hear anything on my side.
Oh,
you were.
I was hearing perfectly, Paul. So thanks.
Good. Yeah. No, but I mean, I was going to say that the problem is convincing the client to take the risk. You know, I was able to, as you say, because it's my own house. But unfortunately, you know, Jamie directed two clients to me that inquired, and one was they wanted to build a house in Barrydale, and the other was a woman in the Kelders, which is near Gansbaai. And both of them then decided not to use it because it was too expensive. So they turned to conventional timber frame.
Yeah. Well, look, I have to, you know, get all that information together to be able to make a decision. But, you know, expensive is a very tall word. You know, it depends on the way you look at it. It's yeah, but obviously it plays a role.
Absolutely, because if you're a developer and you can put up a block of flats, you know, in 2/3 the time that it takes to, you know, you're going to save a lot of time, and time is money. So it's useful from that point of view.
Yeah, but you know, one thinks about the life cycle of the building, which is often overlooked when it comes to commercial developments, where the only sole aim is completion date of the building. Nobody cares about what it does afterwards. You know, which is the architect's bane often, because we are trained to design buildings properly. You know, meaning that there is a thing like you know, called a life cycle. There's effectiveness and climate, you know, climatologically, materials maintenance, all that sort of stuff. You know, developers often don't care about that because they're going to sell the building to the next sucker in the next few months, and then they sit with the problem. Yeah.
Nice. Yeah. Anyway, nice to talk about these things. I hope everybody's enjoyed it. Any other questions?
Yes, Paul, there was a question here, so I'm just reading off the chat. Graham Villian said, super interesting talk. He was wondering about your roof builder. I believe you said you waterproofed with plywood sheet and then glued the cork on top of that. Can I ask what waterproofing was used, and if there are any risks associated with water being trapped in between or underneath the cork layer?
Yeah, sure. It's a tricky one. I won't say that we haven't had leaks, but what we did was, you see, the cork. Well, I mean, the CLT needs to breathe, so we put what they call a vapor barrier, which is a breathable fabric manufactured in Austria on top of the cork directly, and then battens, and then that has the breathing space. So I've got a roof light in my double volume space, which is an operable roof window, and around it there is a chimney which allows air to escape. So the roof breathes on behalf of the CLT, but then on top of the plywood we put an epoxy paint, a waterproof paint. So that theoretically seals the building, the roof, and then on top of that, you put on the cork panels, which are glued on. So it has failed in the valleys, but not generally overall. So, you know, I always thought that this house would be a bit of an experiment, and you know, as I say, we have to address a few leaks, but not many.
Right. Thank you. The second question is from Patrick. Again, saying thank you, very interesting project. Wondering on what R values this method achieves. Also, how is the mass timber handling the annual ranges of moisture content, expansion, contraction issues at joints?
Okay, so you know, everything complies to the regulations in terms of R values. It must be said that both cork and CLT are very well insulated, cork especially. And we've been living in the house for 3 years now, and we live in Newlands, which is very, very wet. And we have not had humidity at all. It's been, well, it's cool in summer, especially with the roof light, which encourages natural ventilation. And in summer on the northeast side, we have the roof overhang of 1 meter, which allows summer sun out and winter sun in. So in winter, it's nicely warmed. And the floor creates a kind of the thick 165 thick timber floor captures the heat, which then radiates during the night. So it's a much nicer place to live than in this damp brick cavity construction part of the house, and also the part which is glass and steel, which is not very well insulated. So I say it's the way to go. It works very well on those levels. Yeah. And again, you know, it's just the timber and the cork. It's not layers and layers of stuff, you know, and it's I like that about it. It's a simple building process.
Okay, great. Thanks, Paul. Last question I've got on my side is, what is the lifespan on the cork cladding?
Well, I mean, a cork, if you take the bark off a cork tree, it grows back in 9 years, but cork trees last hundreds of years. So that's your answer.
Okay. All right. Thank you very much. I don't see any other questions that have come through. And since we're after 4, I'm going to cut it here, if that's all right. Thanks so much for giving us some of your time and doing the presentation, Paul. I have heard already from several people that they did really enjoy your presentation, which is awesome.
Right.
Thanks, everybody.
Any other questions, please feel free to get hold of me. Sure, Matthew can direct you, or otherwise on the Arch Daily site, you know, my details are there. I don't have a website, but I look forward to helping anybody who needs help.
Great. Paul, Patrick did share on the chat. So before you leave the session, you can go and click on the link that Patrick shared. That's the link to the Arch Daily project that you've just shared.
Great.
All right. That's going to be everything on my side. You're welcome. Have a good afternoon. Cheers, guys.
Cheers, guys.